All right, geometry students, we are in lesson 9, unknown angle proofs, but we're actually going to be writing proofs. Yes. So really here we're making the transition from unknown angle problems to unknown angle proofs. So instead of solving for a numeric answer, you guys need to justify a particular relationship, which it says right there. So you should actually be prepared for this because we've been writing a reason for each step of our numeric answers in the last 3 lessons. Every time we get an answer, we're supposed to write a reason for it. Like, why did we do that? Is it a linear pair? Is it a vertical angle? Stuff like that. First, I'd like you to watch the following video. I've put it in your Google Classroom. Just take a second to watch it. I think it's 1 minute, 11 seconds. And just think about while you're watching it, could you follow Sherlock Holmes's reasoning as he described his thought process? So you finished watching that. If you didn't, push pause and please go back and watch it. So let's just talk about things. So in geometry, we follow a similar deductive thought process, much like Sherlock Holmes uses, to prove geometric claims. Let's revisit an old friend, solving for unknown angles. Okay, if you can, remember this one. So you needed to figure out the measure of A and used the fact that an exterior angle of a triangle equals the sum of the measures of the opposite interior angles. Therefore, A must be 36. So we had 78 equals, 42 plus A. Subtract 42 from both sides. A equals 36. Suppose we rearrange the diagram just a bit. So instead of using numbers, we use variables to represent the angle measures. And here we go. So suppose further that we already know that the angles of a triangle sum to 180. Given the labeled diagram to the right, can we prove that x plus y equals z? Oh, sorry about that. Can we prove that x plus y equals z? Or in other words, that the exterior angle of a triangle equals the sum of the measures of the opposite interior angles. Okay, can we do this? I scribbled that off because that's on the next slide. Sorry, sometimes I can't cut and paste very well. All right, so here's our proof. Okay? And really the stuff up here is garbage. This stuff here. Oops. So our proof. First we're going to label angle W as shown in the diagram. It's like when we do auxiliary lines, we need to label an extra angle. So first we're going to label angle W as shown in the diagram. Okay? The first thing that we know is the measure of angle X plus the measure of angle Y plus the measure of angle W equals 180 degrees. And our reason is the sum of the angle measures in a triangle is 180 degrees. The other thing that we know is the measure of angle W plus the measure of angle Z equals 180 degrees. Our reason is linear pairs form supplementary angles. Okay, then we can do some substitution. If this side of an equation equals 180, I can use substitution and plug this in for here. Let me draw that out. So instead of 180, I'm going to write the left side of the equation right here. So I just substituted. I substituted measure of angle X plus the measure of angle Y plus the measure of angle W for 180 equals the measure of angle W plus the measure of angle Z. And our reason is substitution property of equality. Therefore, the measure of angle x plus the measure of angle y equals the measure of angle z. And I'll show you why. The subtraction property of equality. So I'm going to subtract measure of angle w from both sides. And I'm left with this. And that symbol right there stands for the word therefore. It's 3 little dots. It's used in higher level math all the time. So what we did here is we proved the exterior angle theorem, z is w plus x. We proved it by starting out with some basics we knew. We know the interior of an angle is equal to 180. We know what a linear pair is 180. And then we took both of these 180s and substituted them together. So if this equals 180 and this equals 180, then this equals this. We wrote that right here. Subtract w from both sides, and we're left with the exterior angles. All right. Notice that each step in the proof was justified by a previously known or demonstrated fact. We end up with a newly proven fact, which is an exterior angle of any triangle is the sum of the measures of the opposite interior angles of the triangle. This ability to identify the steps is used to reach a conclusion based on known facts, and it is deductive reasoning. The same type of reasoning that Sherlock Holmes used to accurately describe the doctor's attacker in the video clip. All right, so exercises 1 through 6, we're going to go through them together. You know that angles on a line sum to 180. Prove that vertical angles are equal in measure. So first we're going to make a plan. What do we know about angle W and X and angle Y and X? W and X and Y and X are linear pairs, so they sum to 180 degrees. What conclusion can you draw based on both pieces of knowledge? We can draw a conclusion that the measure of angle W equals the measure of angle Y. So let's talk about our proof. First, we're going to use this step. Angle W plus, well, we have to do the measure of angle W plus the measure of angle X equals 180 degrees. Our reasoning is linear pairs form supplementary angles. Then we know the measure of angle Y plus the measure of angle X equals 180 degrees, and it's the same reasoning. Then I can use substitution to say the measure of angle W plus the measure of angle X, I forgot the angle symbol, equals the measure of angle Y plus the measure of angle X. Substitution, property of equality. Then I can subtract both of those out and say the measure of angle W equals the measure of angle Y. And my reasoning is the subtraction property of equality. Cool, so we got to our answer. Okay, next one. Given the diagram on the right, prove that the measure of angle W plus the measure of angle X plus the measure of angle Z equals 180 degrees. Make a plan first. What do you know about angle X, angle Y, and angle Z? Okay. We know that's the sum of interior angles of a triangle. So we know that the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180 degrees. I'm going to write my reasons here. Sum of angles in a triangle equals 180 degrees. Okay, we also know that the measure of angle y equals the measure of angle w. We just proved that. And my reasoning is vertical angles are equal. Therefore, I can substitute measure of angle x plus, instead of measure of angle y, I'm going to put the measure of angle w plus the measure of angle z equals 180. And my reasoning is the substitution property of equality. Okay, that's a abbreviation I've always used. Oops, that's not my eraser. Oh, stink. I can't erase at this point. So, property property of equality. All right. That was messy. Sorry. Next, given the diagram to the right, prove that the measure of angle W equals the measure of angle Y plus the measure of angle Z. That's not quite the sum of interior angles opposite an exterior equals the exterior. But that's okay. We can do it. So what do we know? We know that W equals X plus Z. So let's do that. The measure of angle W equals the measure of angle X plus the measure of angle Z. And my reasoning is a long one. The exterior angle of a triangle equals the sum of the two opposite interior angles. Cool. We also know that these two angles are equal. Measure of angle X equals the measure of angle Y because vertical angles are equal. Therefore, we can say that the measure of angle W equals the measure of angle Y plus the measure of angle Z because of the substitution property of equality. Good. Good job. Oh, I forgot the therefore. All right. In the diagram to the right, prove that the measure of angle Y plus the measure of angle Z equals the measure of angle W plus the measure of angle X. You need to write a label in the diagram that is not labeled yet for this proof. All right, let me erase all of that. All right, let's write down what we know. I'm going to deal with the smaller triangle first. I'm going to write down that the sum of those equals 180. So the measure of angle A plus, that was messy, plus the measure of angle Z plus the measure of angle Y equals 180. And I'm going to go ahead and do the bigger triangle too. The measure of angle A plus the measure of angle X plus the measure of angle W equals 180. The reasoning for both of those is the sum of angles of a triangle equals 180 degrees. Okay, if both of those are equal to 180, then, so if the left side of the equation is equal to 180, and the left side of the equation is equal to 180, then you can substitute and say the left side is equal to the left side. So let's write it down. Measure of angle A, this is the first one. Measure of angle Z measure of angle y equals measure of angle A, measure of angle x, measure of angle w. And that reasoning is substitution, property of equality. Now, I'm going to just do a little bit of canceling and say, therefore, measure of angle z plus measure of angle y equals measure of angle x, measure of angle w. And my reasoning is the subtraction property of equality. And we got it. I'm not sure we need to write a label in the diagram that's not yet labeled for this proof. I don't know what label I would put in there. All right, I'm going to just keep on doing these, and if anything today, I think you need to watch them all, because this is new and different stuff, and proofs aren't easy. I would never want you to think that they are. It's a lot of, it's a process that you're going to get used to as you continue to write them, but it's just not quite simple. So let's try number 4. In the figure to the right, line AB is parallel to line CD. That's what that says. Segment AB is parallel to segment CD, and segment BC is parallel to segment DE. So that's why we have single arrows here and double arrows there. Prove that the measure of angle ABC is equal to the measure of angle CDE. So we're proving that that angle is equal to that angle. Let's do the arcs. That angle is equal to that angle. This would be the first time that we've written the given information. In a proof, often you need to write down what's given. We haven't had a problem that's had any given information yet. Whoops. So I'm writing down what was given in the description of the problem. And for my reasoning, I write given. All right, so that was given. That's our first step. Now let's write down what else we know. Let's see. I think I want to look at those two parallel lines and this transversal. Okay? So if I make those two parallel lines and that transversal, I can say the measure of angle ABC is equal to the measure of angle DCB. Let's mark those arcs. So I've got blue and blue. Those are those are equal because when two parallel lines are cut by a transversal, alternate interior angles are equal. Cool. Now, my drawing is going to get messy. I'm sorry. So now we need to look at these two parallel lines and this transversal. We'll say the measure of angle DCB is equal to the measure of angle. So we just did DCB. Let's do EDC or CDE. And that is really the same reason. So for both of these, I've got the same reason. When two parallel lines are cut by a transversal, the alternate interior angles are equal. Now if you look, let's try to get one more color. I've got the measure of angle DCB, the measure of angle DCB. When those two are equal, I can say that I can substitute. we can say that those two are equal. So it's just like when I had a whole line of stuff equal to 180. We could say a whole line of, I don't know, x is equal to 180, and a whole line of maybe y is equal to 180. We can substitute and say x is equal to y. So let's write that down. The measure of angle ABC is equal to the measure of angle CDE because of the substitution property of equality. Good job. Okay, number 5. That's sort of a fun drawing. In the figure to the right, prove that the sum of the angles marked by arrows is 900 degrees. You need to write several labels in the diagram for this proof. Okay, let's just go around and label the angles. Let's see. I'm going to start here. A, B, C, D, E, F, G, H, I, J, K, ooh, K, L. I, J, K, yeah, that L looks too much like a 1, M. All right, lots of things going on here, all right? The first thing I think I'm going to do is talk about all of these added together. This one and this one and this one equals 360 degrees. And then I think I will say that the addition of all these equals 180 degrees. And then I think I'll add all of these together and subtract that one. Okay, I'm going to add together all of my full circles and subtract my triangle. And I think that should work. So let's work on it. First, we're going to do A plus B. You know what? I'm going to push pause here for a second. I described what I'm going to do. You can rewind and look at that or listen to it again. But go ahead and push pause and see if you can figure out some of the steps all by yourself. That was really fun. I'm going to step through it quickly. You can rewind again and listen to it again. I added up this circle equals 360. This circle equals 360. This circle equals 360 because angles at a point sum to 360. Then I added up, I took all of these and I listed them out. And I added up all of these. And that is the addition property of equality. Then I took just the triangle, C plus H plus I equals 180. Sum of angles in a triangle equals 180. Then I substituted. I took this line and I took out the C, the H, and the I. So I did all of the rest of them. Plus 180, I substituted those 3 letters for 180, equals 1080. Substitution, property of equality. Then I subtracted 180 from both sides. I'm left with all of these, equals 900. Subtraction, property of equality. Woohoo! Okay, number 6. It's the last one. Yay! In the figure to the right, prove that segment DC is perpendicular to segment EF. Draw in label Z. Okay? All right, so let's see what we can do. I'm not sure what label Z is. So let's see if we can figure it out. All right, what do I know here? Let's draw a Z here and see if that helps us. Okay, let's see. I'm going to solve that triangle first. Not solve it, but write down what I know. So the measure of angle E plus the measure of angle A plus the measure of angle, let's erase that and just keep the measure of angle E, F, A equals 180. My reasoning is the sum of the angles, of angles sum of angle measures, not getting the right wording, sum of angle measures in a triangle equals 180. So we can say that, I can substitute 60 plus 60 plus the measure of angle EFA equals 180. The measure of angle EFA equals 60. But that's just math. I'm going to skip right down to the... So ignore the green. I'm just stating some obvious facts. And that would be the... Oops. I've been doing that in red. My reasoning is the subtraction property of equality. Cool. Now let's do the other triangle. So, oops. The measure of angle C plus the measure of angle B plus the measure of angle CDB equals 180. And my reasoning is the sum of angles, the sum of angle measures in a triangle equals 180. Now I'm going to do the same thing. I'm not going to write it out in green this time because we know what the measure of angle C is 60 and the measure of angle B is 90. I can say the measure, oh goodness, the measure of angle CDB is 30 degrees. Okay? I now know where Z is supposed to be. There we go. All right. So we know that the measure of angle, let's go EFA plus the measure of angle CDB plus the measure of angle DZF equals 180. And it is the same reasoning there. Now I can substitute. I forgot to write my reasoning here. Hold on. Right here. Subtraction property of equality. Sorry about that. That's for that step right there. Okay. So that's that reason. We're here. Okay, next step. I'm going to substitute 60. I'm just going to write a little note in green. 60 plus 30 plus the measure of angle DZF equals 180. So the measure of angle DZ, oh, I don't know where that came from, ZF equals 90 degrees. And that is because of the subtraction property of equality. And I'm really sorry I've run out of room, but I don't want to lose what we're doing here. Because of that, because angle DZF is 90 degrees, we can say segment DC is perpendicular to segment EF because perpendicular lines form 90-degree angles. That was sort of fun. In closing, describe deductive reasoning. Deductive reasoning is really the process of drawing a conclusion by justifying each successive step of an argument with a known fact. And deductive reasoning and writing proofs is not simple, but we're going to work through it, and you guys are going to do awesome.